Hello students, welcome back to Vedantu's NCERT Solutions for class 11 and 12. We are going to discuss the third question from D and F block elements. Explain briefly how +2 state becomes more and more stable in the first half of the first row transition elements with increasing atomic number. So we are asked to explain how +2 oxidation state becomes more and more stable with respect to the first row transition elements. So first half of the first row transition elements, that's from scandium to we have manganese. First let me write the oxidation state here. Element, I'll write the element and I'll write the electronic configuration of the respective element. Electronic configuration. I'm going to write the outer electronic configuration here. So argon is the nearest noble gas. So I'll write the oxidation states as well. Oxidation state. So when it comes to scandium, Sc. So 3d1, 4s2. This is the outer electronic configuration of scandium. Oxidation state of scandium is +3 because it can exhibit +3 oxidation state. And if we talk about titanium 3d2, 4s2. So +2, +3 and +4, these are the oxidation states that are exhibited by titanium. Then we have vanadium. So vanadium 3d3, 4s2. +2, +3, +4 and +5. These are the oxidation states that are exhibited by vanadium. And then we have chromium 3d4, 4s 3d5, 4s1. Because half-filled orbitals are more stable. So 4s1, 3d5, and it will exhibit +2, +3, +4, +5 and +6 oxidation states. And then we have manganese 3d5, 4s2, 3d5, 4s2. So it is going to show +2, +3, +4, +5 and +6 as well as +7 oxidation state. Here chromium and manganese, they have half-filled orbitals, 3d orbitals, so they are more stable. And in the question they have asked us why +2 state becomes more and more stable in the first half of the first row transition elements. So what is the answer for this? It can be easily observed here. Except for scandium, all the other metals show +2 oxidation state here. Okay, so I'll write the answer. It can be observed that except scandium, all the other metals show +2 oxidation state. On moving from scandium to manganese. The atomic number increases. From 21 to 25. Scandium has atomic number 21 and manganese has the atomic number 25. So which means that this means that the number of electrons in the 3d orbital increases from 1 to 5. Alright. So scandium 2+, the electronic configuration is going to be 3d1. See here, 3d1. 2 electrons are removed from 4s. Alright. So next we have titanium +2 oxidation state. So it is going to be 3d2. Then we have vanadium 2+. So 3d3. And we have chromium 2+, 3d What is the electronic configuration here? Chromium. So we are going to remove 2 electrons. So it is going to be 3d4. 3d4. Then we have manganese plus 2. So 3d5. So this is half filled. This is half filled. Alright. So plus 2 oxidation state. Plus 2 oxidation state is attained by the loss of 4s electrons. 4s electrons by all of these metals. So since the number of electrons in d orbital, that is 3d orbital, increases from titanium 2 plus to manganese 2 plus, the stability of 2 plus oxidation state, plus 2 oxidation state increases. Because as the d orbital is getting filled, okay. So yes, oxidation state increases. Manganese 2 plus has 3d5 electrons, which is half filled. Hence it is highly stable. So as the plus 2 oxidation state happens in case of these metals, they are reaching the half filled electronic configuration. That's the reason the stability increases from scandium to manganese in their plus 2 oxidation state.